today we are going to be doing an introduction to vectors, starting with the quantities. A vector quantity includes magnitude. An example of this would be distance, time, temperature, mass, or volume. Now for vector quantities, they include magnitude and direction. The direction is the major difference between vector and scalar quantities. Now an example of this would be 10 meters per second east or 9.8 meters per second at an angle of 36 degrees west. In this direction, 20 meters to the north. It will then be hit this way 150 meters, 20 degrees east of north. And the third direction it will go will be 20 meters east, represented by that line there. So our job now is to find the displacement, which is this, and the angle at which it was displaced, which is this. To do so, we need to break these up into x and y components. The y components, comp for short, we will add all of them together from this. So from there, you can get the 200 meters north is positive, and then to find the y component of the second motion, we will do 150 sine of 70. The reason why it is 70 instead of 20 is so from this we get the angle to be 78 degrees. Now for the 78 degrees, what we just found was not that, but instead we just found this. So to get that angle, since this is a right angle, we'll do 90 degrees minus 78 degrees, which will give us 12 degrees, and that is this. So our final answer is the displacement equals 340 meters. What's up, my swag masters? In these next three questions, we'll be talking about vector addition. In this question, A is a vector with a magnitude 4 units pointing to the right. B will be a vector, but we will allow its direction to vary. We will find the magnitude of A plus B when they act at 0 degrees, 90 degrees, and 180 degrees to each other. Since in this first scenario, the scenario has an angle of 0 degrees, it means that the two vectors are pointing in the exact same direction. Therefore, the magnitude of the resultant is the sum of the two vector magnitudes added together. So, 4 plus 3 equals a resultant of 7 units. In the second scenario, the two vectors will be acting at 90 degrees to each other, therefore creating a right angle. And because of this, there will be 3 sides, so it will be a right triangle. Because it's a right triangle, we'll be able to use the Pythagorean theorem to find the resultant. Okay. So one side is 4, one side is 3. With using the Pythagorean theorem, we enter it into this to have 4 squared plus 3 squared. To solve under that, you get 25, the square root of 25, which is 5. So x now equals 5. Therefore, the resultant is 5 units. For the third scenario, we'll have the angles acting at 80 degrees from each other, which means the two vectors will be pointing in opposite directions from each other. So here we have the vector A of 4 units, and since they're 180 degrees and they're pointing opposite, then this vector B, 3 units, will be pointing in the opposite direction. To find the resultant, you will need to subtract the 3 from the 4. So subtract the two vectors and get the absolute value of whatever that answer is. In this case, it is 1. Therefore, the resultant is 1 unit. In this problem, we will be solving for the overall resultant of these two vectors. In order to do that, we need to find the sum of all of the x and y components for both vectors. For the x components from this, you look according to the x-axis. So for the first one, it's 3 and 2, so you add them together to get an overall of 5. And then for the y components of the two vectors, we have 4 and -6. And it's okay to have a negative number because the negative is not relevant. Because obviously you cannot have a negative distance, it makes no sense, walk negative distances. And once you find the overall, you square each of those values and add them together, and then take the square root. And once we did that for this question, we got the overall resultant to be 5.39.
In this demonstration, there are two vectors that are very friendly going in the same direction. Vector A is going 3 meters and vector B is going 5 meters.
3, 4, 5.
Yeah.
In this example, we will have two vectors that will face the same direction. This is not drawn to scale, so please pay attention to the words that I'm about to say. Our vector A, represented by this, is 3 paces. Vector B will be represented by 5 paces. Now, to find the total displacement, we have to do is add these vectors together. 3 plus 5 equals 8. So the total displacement in our demo is 8 paces.
In this demonstration, we have one vector moving 6 paces north and another vector moving 8 paces west. The resultant of these two vectors is 10 paces northwest.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Now how do we get this vector? In this problem, we have one vector going 6 paces north and another vector going 8 paces west. The resultant vector, as we said before, is 10 paces northwest. To solve this problem, all we need to do is use the Pythagorean theorem, since this is a right triangle. Pythagorean theorem is a squared plus b squared equals c squared. So we would square the 6 and square the 8 and set it equal to c squared. That equals 100 equals c squared. Then we would square root. Now we need to find the angle of displacement for this problem so we can have a specific direction. To do so, we need to take the arctan of 8 over 6. This is equal to 53 degrees. This makes the final answer 10 paces north of west at 53 degrees.
No, Jose! Bad boy!
Weirdo. Now we will be solving for the overall resultant of these 4 vectors. We will do so by breaking them up into their x and y components. F1 is 15 pounds, F2 is 20 pounds, F3 is 10 pounds, and F4 is 25 pounds. So we will start with the x components. F1 will be 15 pounds cosine 25 degrees, because F1's degree is right here, 25 degrees. And we'll add that to F2's x component, which is 20 pounds cosine 45. And that will add to F3's x component, which is 0, because it's only pointing in the y direction. And then we will subtract that from F4's x component, which is 25 pounds, because it's pointing in the opposite direction from all the other x components, and then that equals overall 2.74 pounds. And now we'll be solving for the y component. F1 will equal 15 pounds sine of 25, and F2 will equal 20 pounds sine of 45. And then F3 will just equal 10 pounds, because it's only pointing in the y direction, while F4 will be 0 since it's only pointing in the x direction. And then that equals overall 30.5 pounds. Now since we have both the x and the y components, we can use the Pythagorean theorem to solve for this. So it would be 2.74 squared plus 30.5 squared, equaling 30.6 pounds. And now we will solve for the overall degree of these two vectors, which would be the arctangent of 30.5 over 2.74, because we'll be doing y over x, so and that will equal 84.9 degrees. So then the overall answer will be 30.6 pounds at 84.9 degrees northeast. And that will be the final answer of this.
Now we're going to be talking about cross products. In order for a cross product to work the best, it needs to be at a 90-degree angle, so it can have the most torque. This is the equation you would use if you had it at a 90-degree angle. But if you didn't, you would use this angle with the sine theta. Now for dot product, if there is no angle between the vectors, you use this equation, and the two vectors will be going in the same direction. But if there is an angle, you'll use this equation, and that is really all you need to know about dot products.
Why not?
It's just, it's cute, but I don't know, okay. It's cute. I like it.
I like it.
I like it too. It's cute. I'm joking. It's cute.
Yeah.
Okay, it's ugly.
I'm so excited. Okay, we should start
You're right. You should be excited. It's a cute zero.
That hit my goal.
It's just, it looks a lot like a square, but it's cute. Okay,
So
I'll go
stupid,
with it.
man.
Okay,